I would like to present my Project Unity system. It is the most comprehensive multi-video gaming console made that uses only original console hardware without using clone systems or emulation. The objective was to make one base unit that contained all the consoles, one power supply for all the systems, one SCART connector for the audio and visual, and also one master controller for everything. The system was a 3-year project to complete, took about 3,500 hours and about £700 to build, uses about 300 meters of cabling, weighs something around 20 kilos, and contains 15 original video game console systems capable of playing 18 formats in total. Project Unity is designed to fit into a space in a cabinet in my living room, which means the system had to be made with straight sides as it needs to recess into the space available, hence why the system looks a bit boxy. These pictures give an idea of the work required in the project. The build was complicated as Project Unity was designed from the ground up to be an integrated unified system, which is no easy task given that the console systems are proprietary and aren't even happy showing video lines, let alone other electronics. What you see here is one base unit that marries together a stack of retro video game consoles from a variety of manufacturers like Sony, Nintendo, Sega, Atari and others, and make them work as one entity. That is the reason the system is called Project Unity. Building each layer of boards meant making various supports and shelf assemblies in order to support their weight and also keep the boards from coming in contact with each other. This section presents the various console boards included in the Project Unity system and also the rough positioning of the boards too. As you see, the motherboards are quite closely located to each other, but are kept separated. When the system is turned on, only the console board selected receives power. If that was not the situation, the system would need a lot of amperage, and also there would be a lot of interference generated by all the boards, which would cause issues. The boards can be removed if required in order to conduct repairs. It would take a couple of hours to dismantle the unit sufficiently, but it can be done. Bear in mind that some of the console boards included were made over 30 years ago, so at some stage they may fail. I modded 2 GameCube transformers in parallel to provide around 6 amps output at 12 volts DC, which is plenty for the maximum load needed. This voltage feeds into the various step-down and step-up regulators to generate a variety of voltages between 5 volts negative and 15 volts positive. That is necessary as while some systems only need 1 voltage to run, some systems like the Intellivision and the ColecoVision require multiple voltages. The picture shows the regulator section incomplete as there were more regulators added later, but it is fine for illustration. Audio and visual output is via SCART. SCART is used in the UK and is a very versatile television interface as it allows for a screen image to be widescreen or a normal format and also provides connectivity to RGB, S-video and composite modes easily. The master controller is able to work for all the systems because it is a generic controller that can interface with the console's controller board to make it that system. More on that in a moment. Its casing was vacuum formed using 2mm thick styrene. The keypad was from an old Atari peripheral and the buttons from a generic controller, as I felt right when using the system. The jammer female port was originally gripping the interface boards too tightly, so I cut it in half and made it thicker. Buttons, joysticks and other items were added to the internals and connected. This is how the master controller looks like exposed, with the console's controller board interfacing with it. The cartridges were actually Nintendo NES game cartridges, as they were an ideal size and thickness, were uniform and easy to get hold of. The picture on the left is how the controller looks like finished. There are a total of 6 shoulder buttons, 12 keypad buttons, 4 action buttons, D-pad, 2 joysticks, and also a rounded D-pad at the bottom for the Intellivision as a dedicated 8-way controller for it. On the right picture is the connector that goes to the Project Unity base unit, which uses D-sub connectors to allow the base unit to communicate with the master controller. Now on to the Nintendo modded cartridges that contain the console system's controller. Basically, a NES cartridge was deemed to be of adequate size to accommodate a controller motherboard, even if the board needed trimming to fit. The interface between that cartridge and the master controller is via a jammer connector, simply because the boards were easy to get hold of and allowed for enough contacts to work for the project. On the left picture is an example of a completed unit. It shows a Nintendo 64 controller board, which was cut to size and is connected to a rumble and memory board. On the right hand side is an example of the completed decals for a PlayStation cartridge that was also made. So, why not just use emulators instead of using original console hardware? Well, it's a very good question indeed, and probably on the minds of most people viewing this presentation. Most emulators these days, after all, give very good results. However, scratch under the surface, and it is apparent that emulators work well, but have their flaws. That isn't to say that the flaws are enough to make games unplayable, far from it, but they're not one-to-one copies of playing the originals. Irrespectively though, playing on real hardware actually feels different, and also gives the nostalgia feeling which you don't get on emulation. Bottom line, of course, is playing original games on original hardware means playing games exactly as they were designed to be played originally, and that is the best reason to use proper gaming console hardware in my view. You don't just play a retro game, you experience it. One rather unique construction I had to make was a bank of manual switches, as a console system needs up to 9 connections for audio, video and video switching, and 9 for the controller to connect to the master controller. In effect, each console system needs 18 connectors. Each system has to be independent of each other too, otherwise you get conflicts and nothing works. I know it would have been maybe easier to use IC logic chips to do this function, however I do not know enough about electronics to do that. And also, frankly, given the option, I'd much prefer the manual method in any case, as it makes troubleshooting much easier, as in effect your contact either works or it doesn't work. Another consideration was amperage. I probably needed more amperage than an IC gate could probably handle, which of course would be another potential issue. That meant building a unit myself for 18 connections for each of the 15 console systems. The main problem was making a slider unit that was easy to move back and forth, but maintain contact to all of the pins. The unit is made from strips of pine, superglue, elastic bands to keep the pressure on the metal nuts against the wires, and also against the unit to the section. I have used the unit many times. I'm pleased to report that it does work reliably and effectively, and is also easy to repair if required. Here are some completed game cartridges, complete with decals. As previously covered, these actually are Nintendo NES cartridges. As you see here, the actual interface card, the jammer board, is well and truly integrated. These are overlays for the keypad, bearing in mind that some systems, for example the N64, use additional buttons. Rather than overcrowding this area and making things fairly unusable, I came up with the idea of using this, which means that each game can be specifically made with its own overlay if required, so that you not only know what button does what, but also what the features are of it too. The master controller connects to the main base unit via this modded male controller port, and this of course is the slot where the cartridge goes into. So for example, if we wanted to make the system let's say TurboGrafx, all we need to do is to push this home like so, and it is now, to all intents and purposes, a TurboGrafx controller. The master controller has a variety of different inputs, however, various shoulder buttons, 2 analogs, the main action buttons, D-pad, this one which was made exclusively for the Intellivision, as it doesn't do 8-way normally by the usual convention. It's quite an unusual controller, so it's got its own one here. And as previously covered, we have the buttons there for the keypad. This is what the system looks like fully loaded, all the cartridges and discs included. Of course the master controller is now connected as well. Air comes in through these gaps, and there's a 12 volt extractor fan. It's quite a powerful one to bring the air out, and that will keep the air circulating quite nicely. Another point of interest is within each of these doors you can hear a slight click, and that basically signifies if the console is thinking that the drive door is open or closed. Of course the game will work when it is pushed in. Very easy to change the discs as you go along. Pop them back in to play. To show all 18 systems would take quite some time, so I'm going to demonstrate 4. Start off with the Sega Mega Drive. Turn the system on. I'm just going to play a few moments of a game just to show that everything's working fine. What I actually did with the Mega Drive was to put in a tiny switch to change between 60 and also 50 Hz. In NTSC mode, as you see, it fills up the screen, which is quite nice. So, we just started off. Anyway, so on and so forth, get the idea of that. Turn that system off. Change now to the GameCube. Pop it in. Move the slider across. Turn the system on. So I go to run Bomberman Generation. This is one of the reasons I don't really want to show all 18 systems, because you've got to go through all the introductions, which takes a fair bit of time. But this is a good game to show because it demonstrates that the joystick works nicely.
Bomberman Generation!
Forward to the forest!
Where I've been able to, I've made all the games run in RGB mode. Mid-not equal 1% to see, it all works fine. Buttons work well, and also the shoulder buttons to change your view. So, we now turn the GameCube off. Do the same as before, change the system, this time for N64. Move the slider across. Turn the system on.
Nintendo.
And again, this controller is now, in this case, an N64 controller. Get the general idea. And you can see for the joystick that it's all working great. It's actually a very good game. Better than the Tetris Attack. Of course, in this you can use the D-pad or you can use the joystick. Anyway, that shows that works nicely. Move lastly onto the TurboGrafx. It's quite an underrated system. It's got some really good games there, and this is one of them. Galaga 90. Probably the best version of Galaga there is, certainly in my view. So, again, just a quick demonstration of the game working fine. You've seen how quick it is to change the systems and make them work with something new. There you go. So, thank you very much for watching.